Hello student, in this video tutorial I am going to tell you about acceleration and types of acceleration. So acceleration is the rate of change of velocity of an object with respect to time, or we can say it is a ratio of change in velocity by total time taken. It tells how fast the velocity of an object changes with time. That means how fast the body move, or how fast the velocity of the body increases, or how fast the velocity of the body decreases. Okay, the formula of acceleration is change in velocity by time taken. So acceleration is a vector quantity, so it has both magnitude and direction. It follows the same direction as the change in velocity, and it is represented by a small letter a. When the velocity of an object increase with time, that means at 0 second velocity is 0, at 1 second velocity is 2 meter per second, at 3 second velocity is 10 meter per second, at 4 second the velocity is 20 meter per second. That means its velocity is increased with increase in time. So we can say the body is having positive acceleration. When a bus started leaving from a bus stop, its acceleration may be taken as positive acceleration. When the velocity of an object decreases with time, its acceleration is negative. That means the velocity of the body is decreasing with increase with time. Okay, or the negative acceleration is also called as deceleration or retardation. So negative acceleration is only possible if we apply the brake for a moving car or moving vehicle. Okay, or we obstruct someone's journey, some moving object's journey, then we will give that object a retardation force. After that, the body will undergo a negative acceleration. Okay, so example of negative acceleration is slowing down of car after application of brakes. Then unit and dimension. Acceleration is represented by a equal to change in velocity by time taken. Velocity being the unit meter per second and time being the unit second. So we will get the SI unit of acceleration h meter per second square and CGS unit of acceleration h centimeter per second square. So we have the dimension formula of m0 l1 t minus 2. Then type of acceleration. First one, uniform acceleration. So if the velocity changes by equal amount in equal interval of time. So this is the times, this is the what x-axis, this is different position. Okay, in between two position, let's consider the velocity changes by equal same value v वैल्यू. यहाँ पे भी v वैल्यू चेंज हो रहा है, यहाँ पे v डेल v चेंज हो रहा है, यहाँ पे v चेंज हो रहा है, ठीक. पर at every segment the time interval is same, need to be same. So if in between number of segment, at every segment the velocity changes is same and the time interval for the changes occurs is also same, then we can say the body is accelerating uniformly. Okay, then variable acceleration. The acceleration of an object is said to be non-uniform acceleration if the velocity change by unequal amount in unequal interval of time. Okay, then average acceleration. For an object moving with variable velocity, the average acceleration is defined as the ratio of total change in velocity of the object to total time taken. So it's a ratio of total change in velocity to total time taken. Suppose v1, v2 are the velocity of an object at time t1, t2. Then its average acceleration is a average equal to change in velocity by total time taken. Change in velocity means v2 minus v1 by time is t2 minus t1, that is del p by del t. Okay. Then instantaneous acceleration. The acceleration of an object at a given time or at a given point on its motion is called the instantaneous acceleration. Okay, it is equal to the limiting value of the average acceleration of the object in small time interval around the instant t when the time interval approaches 0. Okay, thus instantaneous acceleration a equal to limit del t approaches 0 del v by del t, that after that we will get dv by dt, that is the instantaneous acceleration is the first order derivative of velocity. Okay, but we know v equal to dx by dt, so a equal to d by dt of dx by dt, then we will get a equal to d square x by dt square. So the acceleration is second order derivative of the position. Okay, the acceleration is first order derivative of velocity but second order derivative of position. Okay, then instantaneous velocity is the first order derivative of displacement. Instantaneous speed is the first order derivative of distance. Okay, so this is all about acceleration and types of acceleration. Thank you everyone for watching.